All right, so let's continue our discussion of specific heat. So here's our working formula that the amount of heat that is either given off by a substance or the amount of heat that you add to a substance is going to change the temperature of the substance. And it's going to depend on how much of the substance that you have and then what is the substance made of. So this is the specific heat constant that depends on what the substance is. And what I want to show you is how this formula affects climate. And so imagine that you have an island that is surrounded by water. So maybe it's the Hawaiian Islands. And then let's pretend that we're talking about South Dakota. All right, so South Dakota is over there on the right, Hawaiian Islands is over there on the left. So the South Dakota is going to be made of rocks, and rocks, if you look them up in the chart of specific heats, you find that it is very small. So the specific heat of rocks is going to be a very small constant. And so if you have a certain amount of rock, then the temperature change of that is going to be very, very large. So when the sun shines on rocks, the temperature of those rocks increases very, very rapidly because rocks don't have the ability to hold a lot of heat. So therefore, if this number here is small, this number over here is very big in order to compensate. So in South or North Dakota, during the daytime, then those rocks are going to begin to emit a lot of heat, and so the temperature right above the ground is going to be very, very hot. Now, what about in Hawaii? So in Hawaii, it's surrounded by water, and water has a very, very high specific heat. So it's going to have a large specific heat. And so let's say that you have the same amount of water as you do the same amount of rock. Then that would mean that in order to compensate, the delta T is going to be very, very small. So therefore, the air above the water is not going to change its temperature very much because all of that energy is going into the water and heating it up. So in the Hawaiian Islands, during the daytime, all of that sunlight that it gets, instead of heating up the land, it's going into the water. So that means that there's less energy to go onto the island, so therefore the temperature of the island stays pretty moderate. Okay, at night, when the sun goes down, then the water that is surrounding Hawaii gives off its heat into the air, and then that air is blown onto the island to keep it warm. So at night, the temperatures are not as cold as what you might think, and then during the daytime, the temperatures are not as hot as you might think. Now compare that to North and South Dakota. During the daytime, it gets very, very hot, and then at nighttime, all of those rocks, they give off their heat and they cool off, so then it gets very, very cold at night. So they have extremes in temperatures in North and South Dakota where you don't in the Hawaiian Islands. And Earth has its oceans are about 70% of the surface of the Earth. So the Earth has a tremendous amount of water, and so that helps to keep the climate of the Earth stable. So if the Earth did not have all of these oceans, then the daytime temperatures of the Earth would be much higher than what they are today, and then at night it would be much, much colder. So you see this kind of a climate on a planet like Mars. So Mars does not have oceans, and so it has wide swings in temperature between the daytime and then the nighttime. Okay, let's take a break. When we come back, we're going to talk about changes of state.